Okay, these are our identifying linear function notes. These notes were given, whoops, my screen's moving there. These notes were given on okay, sorry, I was having pen trouble, my bad. Okay, so identifying linear function notes. These notes were given on Tuesday, October the 26th. Basically, students know what functions are. A function is something that, a relation that doesn't have a repeat in the domain or it passes the vertical line test. And so a linear function is going to be a function, again, something that passes the vertical line test or doesn't have a repeat in the domain. That is a straight line. So basically what we're going to do is look at three different pieces of information and be able to tell whether they are in fact a function and then a linear function. So the first one we're going to look at is graphs. We're going to identify first whether they're just a regular function by saying yes or no, and then if they are a function, then we'll talk about the fact of if they're linear. Okay, so I'm going to look at letter A. And I do see definitely that it's a function because it passes the vertical line test. Remember, the vertical line test means that if I was to draw a vertical line anywhere on this graph, it would only touch the graph one time. See, anywhere, even if it's like the y-axis, or if I do one over here, it only touches once. So this is a function, and it is also a linear function, obviously, because it's a straight line. Letter B is a function. Again, it passes the vertical line test just like A did, so that's a yes. But as you can see, it's not a straight line. So although it is a function, it is not a linear function. Now, letter C isn't a function at all. Notice how the y-axis cuts through this picture, and it touches it twice, here and here. That means it is not a function. Therefore, it could not be a linear function either. Letter D is one that's usually a trick problem, although the students have done phenomenally on it this year. If I look at this straight line, I'm thinking, oh yeah, this is definitely a linear function. This actually isn't a function at all. If I was to draw a vertical line down through this vertical line, it touches at an infinite number of places. It touches everywhere on that line. So this one isn't a function at all. Although it's straight, it's not a function, therefore it can't be linear. Our friend on letter E, have a little bit of a debate about this one. We're looking in this general area right here and trying to figure out whether the graph touches once or twice. By nature, I believe this graph literally doesn't go vertical except for in one spot. So I told the kids I would accept yes or no on this one, but I believe this one is a function by the nature of what graph it is, but obviously it is not a straight line, so it's not linear. If you feel like you do the vertical line test, because technically this thing really only touches one time, but if you feel like you're doing the vertical line test and it's touching more than once, on graphs that are questionable, I would accept yes or no. On tests, I usually put ones that are pretty clear cut. You can tell very, very visibly whether they're yes or no. And then our last one is a yes and a yes. It is a function because it passes the vertical line test, and it is linear because it's a straight line. All right, looking at a table, I need to look at my domain values, and I notice that there is no repeat in the domain. Therefore, this table is a function. But to be able to tell whether it is a linear function or not, you need to look to see if it has a constant rate of change. My y values seem to be going down, or excuse me, up 2 each time, and every single time they make a change, they go up 2. On my x values, I notice that those are going down 3, consistently all the way down. So this table is a linear function because it has a consistent or a constant rate of change. Same way with these. Letter A, B, C, they all work exactly the same way. For ordered pairs, I like to create a table like this one. I would take all of these ordered pairs and create a table showing, I just like to find the rate of change in table form. Now you can look at the x values and say that's going up 4, that's going up 4, that's going up 4. Likewise on the y values, you could look at the bottom and say from 3 to 0 it went down 3, from 0 to 3 it went up 3, from 3 to 6 it went up 3. So you've got that visual to look at. I like to draw it in a table. So I'm going to get 0, 4, 8, 12, 16 for my x's, 3, 0, 3, 6, and 9 for my y's. This is going from 3 to 0 goes down 3, and then from 0 to 3 it goes up 3, and then likewise. Let me make sure I'm not missing something. Wondering if there should be a negative. I actually believe on what the kids had, I think that's a -3. Kind of feeling like I don't recognize this problem, so there may be a typo there, but written the way that I'm seeing it on the screen, this would prove to be not a function because it's not consistent, but I believe that this first value is supposed to be negative, which means it's going up 3 also. We have a change of 4 over here, so this would give us a yes and yes. Depending on what you're seeing, if you're a student and you got your notes, look at that value right there and decide whether it's a negative or positive. That would kind of determine whether our table is linear or not, but I really believe that's got a negative on it. I think this was the one that we had that was a no. Let me try this guy and see what happens here. -4, -2, 0, 2, and 4 are my x's. Yeah, he was the no. 13, 1, -3, 1, and 13. See how this goes down 12? And then from here to here it goes down 4, but then it changes directions and it goes up 4, and then up 12. Even though that's a nice pretty pattern, it is not consistent. Our x's are changing consistently, going up 2 every time. So this is a function because there's no repeat in the domain, but it would not be linear because there's not a constant rate of change. Our friend on C is a yes and yes. It is a function and it is linear because of the changes that are happening there. It is consistent. And on our last section, we've got to tell whether the function is linear or not. There's key things that you're looking for, and we gave the students a list of key things to look for. For example, if you have an x squared, if you have an absolute value of x, if you've got square root of x, if your x and y are multiplied times each other, if you've got a fraction where the x is on the bottom, like for example 2 over x, let's see, what's the one for, and as an exponent, let's say we have 2 to the x power. Those would all be examples of things that are not linear, and so we're looking for things that are. So you can take a glance through the notes and see that this would be linear. You've got your regular x there if it was written in standard form. You've got these two multiplied, so that would be a no. We have an exponent on this one, so that would give us a no. Fraction here is okay because our variable's on top, so this guy's in good shape. Here, see how it's on bottom, and that tells us that it's not linear. And then this one doesn't have an x at all. When we get into graphing functions, we're going to see more clearly that y equals 8 will look something like this, up on 8 on the y-axis. But it is a straight line, and it does pass the vertical line test, so that is a linear function as well.